Okay, just a couple of things I want to reiterate from today's lesson. First of all, you came and did a sample of 10 each. Now, I want you to notice something. Whenever I give you a graph or something like this, take a look at your sample size. Notice that SRS means simple random sample. We increase the sample size to 100. Okay? Increase the sample size to 100. When you increase your sample size, you need to realize that you reduce your variability. All right, remember, these little dots mean there's a continuation. That means there was more samples drawn. Now notice, ours earlier today was from 0.35, or actually 36, all the way to 0.7. Okay? Now, if you take a look at, now this 0.36 and this 0.7 was from the samples that we took today for our project. Now, in this one, since we increased the sample size to 100, notice that the variability decreased from 0.45, all right, to 0.45 and 0.7. So this didn't change, but it actually got smaller or got more narrow. That's decreasing the variability. Now, look what happens whenever we increase it to 1,523. It went from here, so it went from here, okay, right here, to right here. So it really decreased the variability whenever we increase the sample size. So that's what I want you to take away from these two charts. All right. Now, this right here, as far as these numbers here, this is just telling you the number of samples we took. Okay? From right here, you can tell that from this line, oh, hold on, there you go. We took about 150 samples just for this column and for this column. So that's about 300 samples in those two things. All right? Now, let's go to the next screen. All right, two types of error in estimation. Bias. Make sure that you know what bias is. It's how far from the true parameter are we getting. Okay, remember, we want it, if this is the true parameter, okay, if this is a true parameter, we want it close to this. We want it, notice how this is spaced out evenly. Another way of doing it, if we do it like this. Let's say if this is my true parameter, if I do that right there, notice that the majority of the data is right on the parameter. Okay, this is evenly spaced this way and this way, so it's still evenly about the parameter. Now, as far as variability, that's how spread out it is, how spread out the values of the sample are. So remember, when you need a good sampling method, you need both small bias and small variability. All right. Remember, to reduce bias, that's this right here. In order to reduce bias, use random sampling. Okay? In order to reduce the variability, we're going to use a larger sample. Those are two main important things. Do not get those mixed up. And then finally, all right, I'm going to talk about this one first. All right? Notice, this is my true parameter right there. This is my true parameter, whatever that may be. Okay? Now, these dots are further away, but they're clumped together. So this is low variability because they're clumped together. This one is high variability because it's spread out. This one down here in C is high variability. Again, they're spread out. I don't know if you can see the dots very well. They're spread out all over the place. And then this one is low variability because the dots are right here in the middle. Now, as far as bias is concerned, notice how far away this is from the parameter. Notice how centrally located this is around the parameter. Again, it's further away from the parameter, and again, it's centrally located about the parameter. Therefore, high biased, low biased because it's around the parameter, and again, low bias. And this right here is the most ideal situation. Okay? And that is, well, I'll take that back. So that basically covers this picture. So let me go ahead and move this out of the way. I'm going to kind of minimize that. let's erase this. All right, now, this sort of falls in the same format. Notice, here's my parameter. These are my parameters. Okay? The distance right here, that means that's going to be low bias. This one is further away from the parameter, so this is going to be high bias. Now again, it's even on this side and even on this side. That means it's kind of symmetrical around the parameter, and so this is going to be low bias, and the majority of them are over here, and a couple of them over here. So this again is going to be high bias because it's not, circled around the parameter. Now, the last thing we're going to talk about is, let's look how spread out these are. This is really spread out. So that's going to be high variability. Okay, so that's high variability. Hopefully it'll pop up. There it is. This one, again, is spread out as well. So that also has high variability. Notice how nice and tight this is. That is low variability. I'm just going to put varia for variability. And again, this has low variability. So this one here is the most ideal. All right? And that's what I want you to take away from this chapter as far as variability and bias is concerned.